Hey everyone, today is the SAT No Calculator workshop in partnership with the Safety Harbor Public Library. My name is Carla Berry, and I'm going to show you everything you need to know about the No Calculator math section on the SAT today. As we wait for more people to join us live, I'm going to share a little poll so that I can get to know you a little bit better. You guys can see me. I can't see you, so this is my way to just get to know you a little bit better. So I'm going to launch that right now. If you can just answer these questions to the best of your ability. If there's a question that you're not really sure how to answer, just put your best guess or skip the question if it lets you do that. I'm not sure if it will let you skip it, but if it doesn't, just put your best guess and that will be fine. So today we are going to be using the College Board's Practice Test 10, and that is actually a real SAT that was used in 2018 by the College Board. So back in 2018, when I was working with students, there were actually quite a handful that took this SAT, and that was the SAT that they used to apply to college, the score that they got from this test. So it's a pretty recent test, which is a great one to start with so that you're using real questions, right, that are going to be similar to what you're going to see on test day. So you all should have received an email from me, and I'm going to just pull it up here and share the link with you just in case you did not receive the email with today's materials. I linked in that email to Practice Test 10 from the College Board, and I also included my worked out solutions and my core concepts and critical thinking skills handout and key. And those are going to be essential as you get started with your SAT prep. So I'm just gonna pull up this email really quickly and then share it with you guys. Let me go grab it here. And you should see this URL for the email pop up in the chat box on Zoom. And you can also use the chat box to send me questions during today's session, or you can use the Q&A feature to ask me a question. And I welcome questions. There's no such thing as a question that is too silly or too obvious. Ask away if there's something you'd like me to clarify. Now is definitely the time during this workshop today to ask any questions you may have that's related to the SAT. So I see most of you have answered the questions in the poll so far. I'm just waiting on a couple more. We'll give it like 2 more minutes, and then we'll dive on in. So far, your responses are pretty across the board for what grade you're in. We have 9th graders, 10th graders, 11th graders, and 12th graders. Today, most of you are in 11th and 12th grade, but that's just by a very small margin. Most of you have not taken the SAT before, but you'll be taking it sometime this fall. There are actually a couple of you that will be taking it in September, which is pretty soon. None of you who have answered the poll so far took the SAT in August. And then some of you, it's a 50-50 split as of right now, have taken real practice tests from the College Board. And then as far as SAT prep, there are 2 of you that have had some prep with me in the past. And then some of you have had prep through your school, Khan Academy, or another program. As far as your goal score for SAT math, that's kind of across the board too. And I will share these results in a minute when I close the poll so you can browse through them too if you're curious as we get started. And then I had a question on here. How many questions do you think most students answer correctly in the SAT No Calculator section when they first take a practice test or a real test? So there are 20 questions on the No Calculator section, and most students, when they first start prepping for the SAT, or if they go into a real SAT test and they take it cold, actually only answer around 5 to 10 questions correctly. So There are some of you who guessed that correctly. Yeah, so it's actually a really rare thing for a student to be answering more than 10 questions correctly in the no calculator section when they first start prepping for the SAT or if they take it cold. Doesn't say it never happens. There are some students where, of course, they are able to get more than 10 questions right during their first attempt or when they first start practicing, but that is not the norm at all. In fact, it's not even the norm for students that are gifted in math. So I have done SAT prep for over 10 years, and I've worked with thousands of students and spent a lot of time, hours and hours with students one-on-one of varying ability levels. So some students are aiming for that perfect 800 SAT math score. They've already taken super advanced math classes in school. And I find that those students encounter similar struggles in the no calculator math section as students that maybe haven't taken those advanced math classes yet or aren't as gifted in math. Those struggles are pretty similar. It's a pretty unique little section. Let's see, are you intimidated by the no calculator math section? Most of you said no or maybe. Let's see which math classes you've taken so far. So it looks like most of you have taken Algebra 1, Algebra 2, Geometry, and only some of you have taken pre-calc so far. So I see some people are still voting. So I don't want to close out the poll just yet. If you just joined, you are able to still submit a question. So the SAT's math section tests you on Algebra 1, Algebra 2, Geometry, and just a little sprinkling of pre-calculus. Pre-calculus is not really heavily emphasized on SAT math. There isn't going to be any calculus on there, but I did include that in my poll question because it's kind of interesting. Sometimes when students, if you're one of the students that selected calculus, that you've already taken that, sometimes when students start with taking Algebra 1 in middle school, or they're really advanced in math by the time they get to the SAT. So it's a long time. It's been a long time since they took basic math like Algebra 1 or Geometry. They're a little rusty, and it can be a challenge once you've started with the more advanced math to think back to the basics. So let's review just really quickly before we dive into practice test 10. And the majority of our time today will be spent looking at real SAT questions from the no calculator section in practice test 10. But I do want to orient you a little bit before we dive in so that you know what I'm referring to when I say certain things. So let me pull that up here. So in the email that I sent out, and I'm going to share my screen. Well, give me 1 second before I share my screen here. In the email that I sent out, I included the core concepts and critical thinking skills handout, which is basically my golden key to SAT success for all sections. So I included that in the email so that you can get a head start memorizing the math formulas and equations that you're going to need to know on test day, and that you can also start reading it through and familiarize yourself with strategies that you can use on the other sections. So I do have workshops coming up in partnership with the Safety Harbor Public Library, just like the one today that will target those other sections. But I recognize that some of you may be taking the SAT before those workshops are live. So we're going to be referencing this core concepts and critical thinking skills handout. And I'm just going to pull it up here. Let me share my screen. Whoops. Here we go. And okay, sharing. There we go. Okay. So in this handout, you'll see on the first page, just basic strategy for each section of the SAT. So just how do you take a standardized test like the SAT? On the next page, you'll see it's broken up into reading strategies and writing and language strategies. And then the last page, front and back, is all about the math section. And these are the math core concepts that you really absolutely have to know when you're taking the SAT. So I don't like busy work at all. So I'm never going to give you things that and tell you, hey, you should memorize this if I don't think it's super important. So what I did, if this is the first time that you're meeting me today, so I actually went through every single SAT published by the College Board within the last decade. And I evaluated every single math question and decided, you know what, how often do I have to teach students the concept that applies to this question? And it would get like a little check mark if I had to teach the concept all the time, and students that I worked with one-on-one frequently missed that question type. Then I also asked myself, how frequently does the College Board actually test this concept on the SAT? So sometimes there are concepts that maybe students struggle with, but they only appear every now and then on the SAT. And then I also asked myself, can a student get this question right easily if they don't understand the concept? So is there a way for them to get to the right answer if they don't fully understand the concept, if they don't have this information memorized? And if the answer was yes to all of those, so yes, it's tested frequently. Yes, most students for some reason forget this information or they don't know it that well. If the answer were yes to those questions and a couple of other ones, I included it into this core concepts and critical thinking skills handout. And I wanted to make it manageable. So it's just one page, front and back for math. And this is the bare bones of what you need to know if you're going to be taking the SAT. There are things that are not included in here. So it doesn't mean this is it. This is just the most frequently missed and the most frequently tested concepts. I assume that you know how to add fractions. I assume that you know that a negative times a negative equals a positive. So I didn't take up precious retail space on this core concepts handout to include that information. So if you find that you are struggling with some of the basic math concepts that maybe you learned a long time ago, or you learned it recently and you just didn't understand it that well, reach out to me so that we can find a way for you to fill in those learning gaps and kind of get to the point where you can just supplement with this handout. I did share the poll results. You guys should have been able to take a peek at the answers to those questions. I'm going to see if anything significantly changed here. And it did not really. I'm glad to see that most of you have already taken a practice test from the College Board. And for the sake of time today, I may not give you that much opportunity to answer the questions yourself. I'll give you a question every now and then to attempt on your own, but I really want to make sure that we maximize my teaching time today so that I can show you what you really need to know in the No Calculator section. Just to circle really quickly, let's circle back to question number 8. In that poll where I asked you how many questions most students answer correctly when they first start practicing for the SAT, or they take an SAT practice test for the first time, or the real test, they go in cold and take it. That's going to be in the range of 5 to 10. You want to aim to be answering 15 plus No Calculator questions correctly. So that's a good goal. If you can get to the point where you're answering 15 or more No Calculator questions, you're in good shape for SAT day. If you are, one thing I didn't, let's check here. So there are a couple of seniors with me today. So seniors this year, you're in a special group if you're graduating in 2021. If you have not taken the SAT before and you need your SAT score for college applications, you need to get your score up. I strongly encourage you to register for more than one SAT test date before you even get your score back, because those test dates may fill up and there's not really enough time between getting your score and signing up for another one to study in that time period. So if you are a senior and you are still aiming to get an SAT score that's going to get you into the college of your choice, I strongly encourage you to just be studying all fall and be signing up for more than one test. So, and not stopping studying after you take a test. You only stop studying once you get a score back that's the score that you want. And I know that's kind of tough. It's a lot, but that's my recommendation to you. So for the math strategies, we're going to zoom in on all the math sections. So both in no calculator and calculator math, we're gonna zoom in and figure out what is the question asking and what concept do we need to know. We're also going to be really careful and watch out for two-part questions or questions that require us to do more than one thing. So sometimes we can accidentally select the wrong answer if we solved for X, but the question really asked for Y. Or we solved for X, but the question really asked, what does 3X equal? And we just forgot to multiply X by 3. So we really want to be careful that we are answering what the question was asking. And we didn't just dive into the problem and kind of lose track of what we were going for to begin with. We also want to think before diving into the question. And this one's a big one, especially on the no calculator math section. SAT math questions, for the most part, are not designed to require a page of math. So most of these questions can be solved in very few steps, showing very little work. So we don't want to be overcomplicating it. That's really, whenever I'm writing follow-up emails to students that I work with one-on-one, it's one of the most frequent issues I see with students is where they're overcomplicating the math problem. So they think it's going to be a lot harder than it actually is. So we want to think, and I like thinking in terms of the core concept. So if I see a question, I'm immediately thinking, hey, is this a parabola? Is the parabola in vertex form, y-intercept form, or x-intercept form? Can I factor the information that they gave me? So I'm thinking that. I'm thinking, did they just give me the equation of the line or an equation of a line? Is this just y equals mx plus b? Do I see a triangle? Do I need to be worried about the domain? Do I see a radical, or is something divided by a variable? So I need to make sure that I'm not dividing by 0. Is this a circle? Does this deal with probability? I am thinking about the question in terms of the concepts that are in this page, front and back. That's my starting point. So before I think of something remote that I learned in Algebra 1 many, many years ago, I'm first thinking of the most obvious things they could be testing me on, which is here. And the only way that that's super useful for you is if you are very, very familiar with this handout and you know it front and back and sideways and you have it super memorized. Exponent rules, super important for the no calculator section. There are some tricks in the calculator section that you can use on your graphing calculator to kind of bypass knowing your exponent rules, but you absolutely have to know them for the no calculator section. We also have this information given at the beginning of every single math section. They provide this reference information, but they don't tell you what the shapes are. So they don't say, hey, this is a rectangular prism, or this is a cylinder, a sphere, cone, or rectangular pyramid. So I like for students to just memorize it, memorize this information, become super familiar with it. So if they can't recall this information from their memory on test day, at the very least, they know it's there. How terrible would it be if on test day you are required to write down an equation or a formula and you're looking back at the reference and information and you're thinking, oh, I think they gave me the equation of a circle, and you look back here and you're like, oh, actually they didn't. You should have memorized that. So you want to be really familiar with what's provided and what's not, and I like for you to even try to memorize the stuff that they give you anyways. And then we have these special right triangles. These are most useful in the no calculator section. You won't need them on every single SAT. So there are quite a few SATs that have been administered even recently where students did not need to use the special right triangle rules. So that's something to keep in mind with this reference information. Just because they provide you with information doesn't mean you're going to need to use all of these formulas and equations on every single test. It's possible to have an SAT and never use those special right triangles, but you should be familiar with them and know how to use them for that one time where they give you a question that contains special right triangles in the no calculator section, and it's just significantly easier to use these triangles than to use the Pythagorean theorem without a calculator. Okay, let's go back up here, and I will share a link in the follow-up email to today to a SAT bootcamp that I taught a little bit ago, where I go through each part of the core concepts handout in detail. So I today mainly want to focus on the questions. So I'm just kind of telling you, hey, this stuff is here. This is where you can find them, so that when I tell you as we're looking at a question, hey, this is a core concept, you're not looking at me like I'm crazy thinking, what is a core concept? I've never heard of this before. So that you know, oh, this is something that's in that handout. And you're going to be shocked today to see how many of the no calculator questions are actually core concept questions. It's pretty impressive how frequently they pop up, and I apply these core concepts to every single SAT practice test and every single SAT that's released by the College Board. Okay, so we already talked about the importance of zooming in and thinking like a test taker. Don't overcomplicate the problem. You want to pause before you dive in. I told you how important it is to memorize this stuff in here. Don't procrastinate. The sooner you start memorizing this stuff, the better. It's not going away. I'm not going to be emailing out an update 2 weeks from now saying, just kidding, you really didn't need to know all of this. You do need to know all of this. So the sooner you get started on it, the better for your SAT score. Strategies. So throughout the SAT, for each section, there are strategies for each one. For math, it's particularly important for you to have strategy in mind because they don't weight the question. So you're gonna get the same point for an easy question as you're gonna get for a hard question. So we do not want to waste our time on super hard questions that maybe we don't know how to solve until we've answered every question on the test. We don't potentially want to sacrifice that easy question, that easy point, in favor of a hard question that maybe even after we've spent a lot of time on it, we still make a silly mistake and don't get it right. So we want to keep track of time and make sure that we're picking up all those easy points first. We also want to show our work. Remember, we're not going to have a ton of work ever for the most part, but the work that we have, we want to show on paper. So even if you're able to answer questions in your head, and I mean, I do SAT math and verbal for a living. So I, out of anyone, am super capable of answering these questions just in my head without showing any work. And even I don't do that because, you know, when I am answering things in my head, if I get distracted for a split second, or something just goes awry in my head, maybe it only happens once every 1,000 times and I make a silly mistake. That is too high of a risk on the SAT. This is an important test. So I always show my work, even for the super easy questions, just to make sure that I don't make a silly mistake. And that also enables me to easily go back and check my work at the end of the test to make sure that everything is correct. Okay, let's see here. So graphs, we're always going to identify the slope, the x-intercepts and the y-intercepts. We're gonna read the labels. We're gonna pay attention to the scale. And I already mentioned you need to know the parabola equations, the equation of a circle. You should be familiar with triangles, equations for a line, factoring the y-intercept, the x-intercept, and the slope. Let's see here, area of a sector and arc length pops up all the time on the SAT. SOHCAHTOA, that's just this little bit here is basically the only trig that you need to know for the SAT. So very, very little. The trig table comes into play in the no calculator section, not on every single SAT, but if it does appear on your SAT, it's worth knowing it, which is why I gave it that precious retail space right there. You should know the basics about parallel lines, how to find the distance between two coordinates, and how also to find the distance if you're given the rate and the time, or to find the time if you're given the distance and the rate. You should know that I is the square root of -1 and I squared equals -1. You should know how to find the midpoint if you're given two coordinates. You just add the x coordinates, divide by 2, add the y coordinates, and divide by 2. You should know the quadratic formula. I don't use the quadratic formula a ton though on the SAT at all. I prefer completing the square personally. If you are not comfortable with completing the square, or you've never even heard of completing the square, then you absolutely should know the quadratic formula. However, what I do use super frequently on the SAT is the discriminant. And the discriminant is what's under the radical for the quadratic formula, that b squared minus 4ac. Remember, our a, b, and c just comes from a quadratic or a basic parabola written in y-intercept form. A is the x squared coefficient, b is the x coefficient, and c is our constant. And that discriminant comes so handy on the SAT. The discriminant tells us how many solutions we have. So if our discriminant is positive, we have 2 real solutions. If it's negative, we have no real solutions. And if it's 0, we have 1 real solution. The SAT won't really ask you to use the discriminant. It won't explicitly just state, hey, please use the discriminant to answer this question. Instead, you will see little clues. And those clues will be, which one of these gives no real solutions? Or which one of these gives 1 real solution? So whenever I see the number of solutions mentioned in an SAT question, I'm immediately thinking, I'm gonna need to use the discriminant. Absolute value, you should know the basics of how to answer an absolute value equation. We isolate the absolute value expression. Then when we remove those absolute value bars, our absolute value bars are basically our positivity maker. It makes whatever's inside the absolute value bars positive. So when we remove those absolute value bars, we have to set it equal to a positive and a negative, and we solve those 2 equations separately. An SAT favorite in recent years is no solutions versus infinite solutions. You are pretty much guaranteed to be tested on this concept on the SAT. I don't know if we're gonna get into the nitty-gritty of this today or in the calculator section, we'll have to see. But this is a pretty much guaranteed advanced math, so it's going to be classified as hard by the College Board type of question on your SAT. So whenever you see in a question that no solution is mentioned and they gave you the equation of a line, you want to think that you have parallel lines, so they're going to have the same slope. And if you read infinite solutions, you want to think it's the same line. So they're going to have the same slope and the same y-intercept. I see Angelina asks, will we be getting these notes? And these notes are in your email. So I will actually, let me open up the email really quickly to show you where they are in there. They're kind of hidden, maybe like a little bit in the email. And I will also share the recording. Let me make sure I am recording. I am. I will also be sharing the recording of today's session. So if you go into the email, you will see that the key to the math strategy is linked right here. And then all of my worked out solutions for practice test 10 is linked here. The first 3 things that I linked are just the standards. So this is a blank core concepts and critical thinking skills handout. So you can use that to kind of test yourself. And then a blank practice test 10, and then just scoring for practice test 10. As we're about to get ready to dive into some questions, let's just take a second to look here at the scoring for the math section. So the math section's the easiest one to determine your score. You just add up how many questions you got right in the no calculator section to the number of questions you got right in the calculator section. That gives you your raw score. And then you find it in this left-hand column. And then you can see how that score scales to your actual SAT score. So let's say you got 40 questions out of 58 questions correct, and both math sections combined. So if you added up all the questions you answered correctly, you would have a math score of 590. Let's say that you only missed 6 math questions. That would give you a math score of 700. And that's 6 questions combined from both the no calculator and the calculator section. So I just want to say something really quickly here about improving your math score. You basically need to take the math practice test, those sections, twice at a minimum. And I know that sounds like a lot, but it's the tried and true way to improve your math score on the SAT. And I have seen this work with so many students. So I can tell you, hey, this is the way, and not feel bad about just how much time it's going to take you to do this. So how does this play out? When you first start taking SAT practice tests, don't time yourself on the math section. Just see which questions do you actually know how to answer, and try to answer all of them, even ones where you're maybe not 100% comfortable with how to answer them. Then after you're done taking that practice test, go and look through the answers to the questions, figure out how to get to the right answers, study the questions, study the answers, really understand the concepts for every single math question. Once you feel like you understand the question super well, then you want to retake that math section and see if you can get 90% or more of the questions correct in each section. So you're really aiming for close to perfect. It's okay, don't worry that you're just going to remember the answer is B, because you still have to show your work. So if you don't know how to get to B or how the answer is A, you're going to mark that question as incorrect, and you're going to review it again once you're done with that retake. But the retake is so important for SAT math. You cannot just take a practice test one time and then move on to the next practice test. You are not going to see the same score increase as you would if you took those math sections, actually go back and study them, understand those question types, and then retake the sections to test your understanding, and then review again if you missed any questions before you move on to the next practice test. What I love about the SAT, and especially about the SAT math, is it's super predictable from test to test. They are not reinventing the wheel at all. We know pretty much exactly what to expect. Sometimes they will ask the same question or test the same concept in a little bit of a different way. But if you get super familiar with what kinds of questions they're going to ask, you're not going to be intimidated because you're not going to have that fear, is this something I maybe just didn't learn? Because you will feel so comfortable with the fact that you already know everything you need. And that's a place where I want you to get to. Okay, let's just take a peek at a couple more math things, and then we're gonna do some rapid math here. So we looked at no solution versus infinite solutions. Exponent rules, I already said, super important. So let's actually go look at, oops, wrong thing. Where did it go? Practice test 10. And the no calculator section is section 3. You have 25 minutes for 20 questions. Get to know these directions really well before test day. You should not have to use any of your time to read the directions. You should already know them really, really well. The questions are pretty much ordered for the most part from easy to medium to hard. So the first couple of questions should just be basic algebra, very basic geometry type questions. They shouldn't be too hard. That doesn't mean that every now and then they don't give you a whammy of a question as number 2. And if that happens, if you're only at question 2 or 3 and you're thinking, oh my goodness, this is really hard, and this is supposed to be still in the easy part of the test, just skip it and come back to it at the end of the test. So after you're done answering all of the other no calculator section questions. So it's not a big deal, take a deep breath and move on. The best skill you can have for standardized test taking is being okay to skip over a question and just coming back to it at the end. That perfectionism, and I am a perfectionist, I'm a type A, I wanna answer everything, I wanna get everything right. So it's really hard for me to skip over things. But I know for standardized testing, I am going to do exponentially better on a test if I feel comfortable with just skipping things and answering everything that I know really well first. Okay, so it goes from easy to medium to hard. So the first couple of questions are should be easier. And then it gets kind of like into the medium territory. So it's going to be a little harder. And then it starts getting hard conceptually. So it's more advanced math, it's conceptually harder. And then after question number 15, 15 is the last multiple choice question. After 15, we get to these free response grid-in questions. So we're out of the multiple choice section, and it's super important for you to know that once you reach these grid-in questions, the difficulty resets. So you have to mentally take a deep breath, or physically actually take a deep breath and remind yourself, hey, the difficulty just reset here. It's about to get easier first. So questions 16 through 20, again, it's going to follow that pattern of easy, medium, and then hard for the most part. So with question number 16 and even question number 17, you want to make sure that you are not overcomplicating those questions. Right after you've answered question number 15, you are functioning at a higher level. You're thinking more deeply, more critically. So you're at risk for overcomplicating those first grid-in questions, and you're not going to do that, right? Okay, so let's go through these questions in rapid fashion. Let's see how we should answer them on test day. So you should all be in section 3 of practice test 10, and you have access to my worked out solutions. So if you find that I'm going really fast and you're like, oh, I didn't get to write that down and she's already moving on to the next question, that is okay. So our first question here, what value of z satisfies the equation above? This is pretty much a guaranteed question for you on test day, solving an algebraic equation. They can give you a question like this either as an easy one or a medium one or a hard one. You should really brush up on this if you're not comfy with this already. I like keeping my variable positive at all times on standardized tests and even outside of standardized tests. So since I have 2z here, I'm just gonna leave my z on the left side and subtract z from both sides and subtract 1 from both sides, and that's going to give me z equals -1. And we're going to double check that this question actually asked for z, and it did, so we can just select B and move on there. For number 2, I immediately glance at the answer choices whenever there are equations. So here you should notice these are all in the form of y equals mx plus b. Super common on the SAT. Get really good at noticing y equals mx plus b, and you're gonna get so many freebie points. So all of those are in the form of y equals mx plus b. This is a core concept. Our slope is m, and b is our y-intercept. So as we read this word problem, we just need to figure out which part's the slope and which part is the y-intercept. So we see here a television with a price of $300 is to be purchased with an initial payment of $60. Initial payment, starting amount, those are all code words for the y-intercept. So I want a plus 60. That only occurs in answer choice C. Boom. So I am done after only reading part of the first sentence. I would still go and read the rest, or I would just circle this as, hey, I need to come back at the end and make sure that I read it completely and check that I picked the right answer, but it has to be C, right? Let's look here at the next part. They say weekly payments of 30. That's going to be our slope. So we want a 30. We can see that happens in more than one answer choice, but it can't be D. So that just affirms for me that it has to be C. Super duper easy, super duper common SAT question type. Let's look at number 3. So they give us a table here. Whenever they give me a table on the SAT, I'm always looking for my X and Y intercept. So I'm looking for zeros. In this case, they don't give me any zeros, so I'm kind of out of luck there. If I don't see any zeros, I'm looking for my next best thing. In this case, it's going to be that 10, because multiplying something by 10 is really, really easy, right? And if we look at these answer choices, hey, what do you know? It's y equals mx plus b again, right away, right? That's kind of crazy. 2 y equals mx plus b questions in a row. It's tested so frequently on the SAT. Okay, so they want to know, they say the table above shows shipping charges for an online retailer that sells sporting goods. There's a linear relationship. That is also code for y equals mx plus b whenever there's a linear relationship between the shipping charge and the weight of the merchandise, which function can be used to determine the total shipping charge, f of x. So I'm just going to label that column, the shipping charge, as f of x in dollars for an order with a merchandise weight of X pounds. So I know my first column is X. I could solve for my slope by finding that my slope is the change in Y over the change in X. So I could say, let's say 21.89 minus 16.94 over 10 minus 5, but this is a no calculator section. And if you get to know me, you will know I only like doing the work that I need to get to the right answer. Otherwise, this wouldn't be fun for me, right? I do this as my job, so it has to be a fun thing. Way easier thing to do here than finding the slope is going to be to just plug in that 10 for X. So that's what I'm gonna do. So if I plug in 10 for X and I multiply each of these, so each of these X's, I'm just gonna make 10. It's going to move this decimal over by 1. So that's going to give me 990 here, because 0.99 times 10 gives me 990. For B, that's going to give me 990. Let me just move this over a little bit. 990 plus 1199. C is going to give me 3390. and D is going to give me 3390 plus 1694. And I know when X is 10, Y, or F of X, has to be 21.89. So 990 for A is too small, 3390 for C is too big, and 3390 plus 1694 for D is way too big, so it has to be B, 990 plus 1199. If I had time at the end of the test, I can go do that math and see, hey, what is 990 plus 1199 equal to, and I'd figure out that, hey, that is 9, and then like so that's, oops, 1, yeah, that's 21.89. Do I do that work right off the bat? No, because I already know it can't be A, C, or D. It has to be B, and we can just move on here. Let's look at number 4. So here they give us a graph, but our graph is not labeled yet. That is basically an invitation or a call of action for you to label it. So they say here that the line in the XY plane above represents the relationship between the height, h of x in feet, and the base diameter x in feet for cylindrical Doric columns in ancient Greek architecture. So I can label the y-axis as the height and the x-axis as the base. How much greater is the height of a Doric column that has a base of 5 feet? So I'm going to circle 5, then the height of a Doric column that has a base of 2 feet. So we're dealing with 5 and 2, and we're concerned with the height. So we want to make sure we're not accidentally just saying 5 minus 2. We're doing something silly here. So when the base is 2, the height is 14. When the base is 5, the height is 35. So I just want to know what is 35 minus 14, and that's going to be 21. I show all my work here, and I am actively labeling my graph. When I'm working with students or I'm proctoring a test and I look at their pieces of paper and I see graphs that don't have any rating on them, I already know the student probably didn't answer the question correctly. So make sure that you are actively annotating and rating on your graphs whenever they give them to you. Let's look at number 5 here. So if x is greater than 0, that is just our domain. They're saying we are not taking the square root of a negative number and dealing with I here. Which of the following is equivalent to the given expression? So if I take the square root of 9, that's going to give me 3. And if I take the square root of x squared, that gives me x, because think of it, x times x is x squared. So I just want 3x. Most common mistake that students make here is picking B, because they only take the square root of 9 and they forget to also take the square root of x squared. And that happens when you rush and you don't show your work. So 5 should be a pretty easy point for you to pick up. Let's look at number 6 here. What are all values of x that satisfy the equation above? I immediately spot I have an x in the denominator and I cannot divide by 0. So I cannot have C as my answer choice, because 1 minus 1, if x is 1, that makes the denominator 0, and I cannot have 0 in the denominator. I can't divide by 0, so it cannot be 1. I could solve this question by plugging in my answer choices. So plug these in. Whenever you have variables in the question stem and numbers in the answer choices, that's a hint that you can just plug in your answer choices. So you could go -3 squared minus 1 over -3 minus 1 equals -2. See if that's true. So that would give you 9 minus 1 over -4 equals -2, and that's not -8, that's 8 over -4 equals -2. And yes, that is true. And then you would have to do the same thing to check -1. But it only actually ends up working for -3, so you would pick A. That's how you can use the answer choices to solve this. You can also eliminate that fraction by multiplying each side by x minus 1. That cancels out the x minus 1 in the denominator, and it gives you x squared minus 1 equals -2x plus 2. I am just, or actually I'm not going to distribute yet. That gives you -2 times x minus 1. And whenever you can factor something on the SAT, you should. This is a core concept. Basic factoring, you should know. X squared minus y squared factors to x plus y times x minus y. So this is just going to factor to x plus 1 times x minus 1 equals -2 times x minus 1. We can now cancel out our x minus 1 on each side, and that gives us x plus 1 equals -2. So x equals -3, which also confirms the answer is A. Let's look at number 7. 7 is another core concept. 7 should take you maybe 10 to 15 seconds to answer on test day, because f of 0 is asking you what is y equal to when x equals 0. So they're asking you for the y-intercept. Core concept to know this. So all we need to look at is what is our y-intercept, and we can see right here our y-intercept when it crosses the y-axis is 4, so it has to be D. Super common for the SAT to ask you about x-intercepts and y-intercepts. Let's look at number 8 here. In the figure above, point B lies on AD. What is the value of 3x? We recognize that we have a 90-degree angle on the left-hand side, a straight angle, so this all together equals 180 degrees. So we have a right angle on the right-hand side too. So we can say that x plus 2x plus 2x equals 90. Combine our like terms, so 5x equals 90. Divide both sides by 5, so we get x equals 18. If you need help with long division, if I divide 90 by 5, I think a 5 goes into 9 one time. 1 times 5 is 5. I subtract, 9 minus 5 is 4. Bring down that 0. 5 goes into 40 18 times. But let's not fall into the trap of selecting A as our answer, because they are asking for 3x. So we need to make sure that we're multiplying x, our 18, by 3. And 3 times 8 is 24. 3 times 1 is 3, plus 2 gives us 5. So our actual answer is 54. And I've seen so many students accidentally put A for this answer just because they rushed and they put down what x was equal to instead of putting down what 3x was equal to. That's a painful mistake to make. Don't do that on test day. For number 9, we basically have an equation of a line again. And they even tell us that. Hey, equation of a line here. So this is y equals mx plus b. But we have a slight problem. All of our answer choices are in standard form, ax plus by equals c. And this is on the Core Concepts handout. This is a super common question type. So instead of rearranging all of those answer choices into y equals mx plus b form, which I am more comfortable and familiar with, I am just going to solve for the equation of a line in terms of y equals mx plus b, and then rearrange it into standard form. I'll show you what that looks like. So first, I know that my b, my y-intercept, has to be -4, because I can clearly just see that on the graph. But for my slope, I like actually using the slope formula to find slopes on the SAT instead of finding them by just counting on the graph, because often on the SAT, you do not have the same scale. So it's really important to not fall into that trap. So I like just taking an extra minute and finding the slope. So we're gonna say slope is the change in y over the change in x. And I'm going to use my two intercepts. So I'm going to use my y-intercept and my x-intercept. So I'm going to say -4 minus 0 over 0 minus -4. And that gives me -4 over +4, which is -1. So I have y equals -x minus 4 as the y equals mx plus b, my equation for this line. To get it to look like standard form, which is all of my answer choices, I just need to add x to both sides, and I get x plus y equals -4, and that is answer choice C. Who can tell me an alternative way to answer question number 9 correctly, in case you forgot all about y equals mx plus b on test day, and you don't know how to find the slope, you just draw a blank? How can you get this answer? How can you get this question correct? How can you get to the answer without knowing how to find the slope, without knowing anything about y equals mx plus b? How can you get there? Let's see here. Yeah, so someone said plug in the points into the choices. So you could plug in the coordinates. So you could plug in, let's say -4 for x and 0 for y into all of the answer choices and see which ones are true. When you plug in points, it's important to plug in more than one point or more than one coordinate, because it may not eliminate all of the wrong ones. So you want to make sure that you take your time and plug in more than one. But that's an alternate way for question number 9. For question number 10, they give us a parabola. So I am immediately thinking, whoops, of my parabolas over here from the core concepts. So they give me a parabola, and I'm just going to pop this right here. And I can see, oh, that equation of the parabola that they gave me is in y-intercept form. It's in this form. So 12 is my y-intercept. And then they say if the graph crosses the y-axis at the point 0k, what is the value of k? And we're going to use another core concept, which is that whenever they ask you for 0 and then a number or a variable, they are asking for the y-intercept. So this should be a 10 to 15 second question for you, that k is just the y-intercept. So the answer here is 12. I would shed a tear of pain if you got this question wrong on test day, because it's frequently tested and you should just take the time to memorize the 3 different equations for a parabola and how to spot y-intercepts and x-intercepts on the SAT. Number 11, we're going to use another core concept, and I'm just going to go grab it here. Boom, boom, boom. Where do we go? The equation of a circle. And we may go a little bit over time today, and that's okay. So we have, if you need to leave right at 6 p.m., you can always catch up with whatever part you missed out on the recording. So a circle in the XY plane has a center of 5, 7. So that is my H, whoops, that is my H and K. So I need X minus 5 and Y minus 7. And that occurs in answer choices A and C. So it cannot be B or D. And then the radius is 2. And I can see here that my radius needs to be squared. So it needs to be equal to 4. So it cannot be C, and my answer here has to be A. This should be a super quick question for you on test day. Let's look at number 12. So they give us 2 triangles. So in my mind, I'm thinking about, what are my core concepts for triangles? And I'm just gonna grab them right here. And they say in the figure above, triangle ABC is similar to triangle DEF. And similar triangles have the same respective proportions and trigonometric ratios. What is the value of cosine E? So I also need to use SOHCAHTOA. So I'm gonna go grab another core concept from the back page here. Whoops. And we don't need everything here. We just need the basics about SOHCAHTOA. Okay. So when they're asking, hey, what is the value of cosine E? The triangle ABC and triangle DEF are similar. So cosine of E is going to be equal to cosine of B. So I don't even really need this other triangle at all. I can just say cosine of E. I'm going to do my work down here. Cosine of E equals cosine of B. And cosine of B is just going to be adjacent over hypotenuse. Adjacent is the 12, that's adjacent to angle B. And the hypotenuse is opposite to, or it's across from that right angle. The hypotenuse never changes. That's always the hypotenuse. So I just need 12 over 13, and that is answer choice B. So not that terrible of a question. Let's look at number 13. So in the XY plane, the graph of the function has 2 x-intercepts. What is the distance between the x-intercepts? So that's a parabola, and it's in the x-intercept. They want the x-intercept form. They say there's 2 x-intercepts. And when I look at my parabola core concepts, I can see there for my x-intercepts, I'm gonna need to factor. And even if you didn't make that connection on the SAT, if you can factor something, you 100% should factor it. So we are going to say that f of x equals, and let's factor that. I always like opening up my parentheses first. I'm only going to need positives here because I only have positives over there. X times x gives me x squared. And let's see here, 1 times 4 gives me 4, and 1x plus 4x gives me 5x for my middle term there. So that's factored correctly. So then my x-intercepts means that y has to equal 0. So 0 equals x plus 1 times x plus 4. I get 2 equations, x plus 1 equals 0 and x plus 4 equals 0. So x equals -1 and x equals -4. And my distance between the x-intercepts, I can either draw a number line and say, okay, here I have -4, -3, -2, and -1. And my distance between those would be 3. Or I can use absolute value and say -4 minus -1 equals 3, or -1 minus -4 equals 3. Doesn't matter which way you get to the 3, there are multiple ways. Let's look at number 14. What are all the values of x that satisfy the given equation? So on the SAT, it's super important whenever you see radicals, especially even square roots or even roots, to watch out for the domain. You never want a square root equal to a negative. We do not want that. So we're going to start by just plugging in our answers. We don't actually have to solve the equation because they already give us the possible solution, so we just need to check them. So let's plug in that 1. So 4 times 1 equals 1 minus 3. That gives me the square root of 4 equals -2. I can't have that. Remember, I cannot have an even root equal to a negative number. So it cannot be 1. So it cannot be A and it cannot be C because both of those include Roman numeral 1. Next, we're going to check our 9. So 4 times 9 equals 9 minus 3. That's going to give me 36. The square root of 36 equals 6. That works. I have an even root equal to a positive number. That's fine. So 9 works. So it has to be B. For number 15, I really want you to pay attention. Of course, every single question we've covered so far has been important for the SAT. There are no questions in this no calculator section that I can honestly tell you not to worry about for test day. They are all important concepts. Number 15 is particularly important because it's a more challenging concept, but once you get comfy with it and you really understand it well, this question type actually becomes super easy. So the first clue that I see is that I have 2 equations in standard form. So I have ax plus by equals c here. And I have 2 equations with 2 unknowns. My next clue is they tell us that a is a constant, and then they ask us for which of the following values of a does the system have no solution. So remember, when you see no solution, you want to think of a parallel slope because the 2 lines are never going to cross. They're going to look something like this. And a solution is when they intersect, and these lines are not going to intersect. And so they're going to have a parallel slope or the same slope. And our slope is determined by the x and y coefficients when we write equations in standard form. So we want these coefficients for x and y to be the same. Well, I have a problem. For the second equation, I have an a there. I don't even know what the a is. That's what I'm trying to figure out. But then I also see I have that 2. So I want my coefficient for y in the first equation to be 2. So I'm just going to multiply everything in the first equation by 2, and that's going to give me -6x plus 2y equals 12. And then let's just write our second equation down below. And now it's really easy to see. My y coefficients are the same, so my x coefficients also need to be the same because that's the part that gives me my slope. I don't really care about the part that's going to give me my y-intercept. When you see no solution and infinite solutions, that means we are just concerned with the slope. And I can easily see here now that -6 equals a, because those coefficients need to be the same, just like my y coefficients are the same. It becomes a really easy question once you wrap your mind around that concept. Okay, let's go on here to question 16. So they give us an equation. A manufacturer shipped units of a certain product to 2 locations. The equation above shows the total shipping costs, T in dollars for shipping C units to the closer location and F units to the farther location. If the total shipping cost was $47,000, so I can just plug in 47,000 right there. And 3,000 units were shipped to the farther location. So I can say F equals 3,000 and T equals 47,000. I'll actually just do the equation down here. How many units were shipped to the closer location? What does C equal? So we're just gonna say that 47,000 equals 5C plus 12 times 3,000. So 47,000 equals 5C plus 36,000. 36,000, there we go. I like keeping my variable positive, remember? So I'm gonna leave my 5C alone, and instead I'm going to subtract 36,000 from each side, and that's going to give me 11,000. Oops, that cancels, equals 5C. So I need to divide 11,000 by 5. 5 goes in a 1 0 times. 5 goes in an 11 twice. 2 times 5 gives me 10. I'm going to subtract. 1 minus 0 is 1. 1 minus 1 is 0. Bring down that 10. 5 goes in at 10 twice. 2 times 5 is 10. Subtract again, and then I'm just going to bring down those zeros and add my zeros there. So my final answer is 2,200. This is the most work we're going to do for any question on the SAT. So I want you to really notice something here. Easy doesn't mean fast, and hard doesn't mean a lot of work or long. Once you get really good at understanding no solutions versus infinite solutions, a question like number 15, even though it's conceptually hard, should take you 30 seconds or less. It should be super fast. Or a question like number 10 or 11 or 12, super fast, even though conceptually, because you have to know those formulas and equations and really understand them well, they're a little bit harder, but they're fast. Sometimes the easier questions can take more time. So if I notice this is going to take a lot of time, I am not ashamed to skip that question and come back to it at the end. So I'm not burning out and using up all my precious minutes on a question that's just eating up my time. Let's look at number 17 here. So absolute value, this is a core concept, right? And I have the directions to solving an absolute value equation on the back of our core concepts here. So I'm just gonna pop it here as a reminder that it is a core concept. But what we're gonna do here, our absolute value is already isolated. So we're just gonna pop off those absolute value bars and have 2x, whoops, 2x plus 1 equal to 5 and 2x plus 1 equal to negative 5. So we have two equations, one's equal to a positive, one's equal to a negative, and then we're gonna solve for x. Remember, we keep our variable positive, so we're just gonna subtract 1 from both sides for each equation, and then we're gonna get 2x equals 4 over here, and 2x equals negative 6 over there. So x equals 2 or x equals negative 3. And they say if a and b are the solutions, so a and b are 2 and negative 3, what is the absolute value of a minus b? So we could say, hey, what is 2 minus negative 3 equal to? Or what is negative 3 minus 2 equal to? And both of these would equal 5. It doesn't matter which way you do it, you're going to get 5 as your answer. Just as a little side note, for the grid-in free response questions, you can never have a negative. There's no way to grid in a negative answer choice. So if you ever get a negative, you either did something wrong and you need to go redo your work. If you don't have time to redo your work, then just drop the negative from your answer and grid in what you have. So for 18, this is a percent question, and this is also a core concept, no surprise. I'm like a broken record with these core concepts, but they're so important and they're not going away. So let's just see here what we need to know. So for percent problems, if the original amount is not given, we're gonna pick 100. Doesn't matter if it's reasonable or not. If they say, I drink X number cups of coffee a day, we're gonna say, I drink 100 cups of coffee a day and work with that. If we need to find the percentage of something, that's just the part over the whole. Or if we need to find our percent change, that's the difference over the original. And then these last two that I have starred are super important. So when we see increased by a percent, we take that percent express it as a decimal and add it to the number 1. This is so important for the SAT. When we see decreased by 1%, we take that percent, express it as a decimal, and we subtract it from the number 1. So if I ever read in a problem that something increased by 30%, that would mean I have 1 plus 0.3, and I'm going to think of that statement in the word problem as 1.3. If I see decreased by 30%, I'm going to think of that as 1 minus 0.3, and from that point forward, I'm going to use 0.7 instead. So when we read this question and we see one purchased an antique that had a value of 200, so that's our original value. Each year, the value of the antique is estimated to increase 10% over the value the previous year. So we're going to take that 10% and make it a 0.1, and then we're going to have 1 plus 0.1, which is equal to 1.1. The estimated value of the antique in dollars 2 years after the expression or after purchase can be represented by the expression 200A, where A is a constant. What is the value of A? So we have more than one year here. Organize your info, it just makes it exponentially easier. So whenever I see I have year 1, year 2, year 3, I'm just gonna label it. So year 1, I'm just going to have 1.1 times 200. That's pretty easy. For year 2, I'm gonna need to use, and I'm just gonna make this in yellow, I'm gonna have my starting amount be year 1, right? But I need to multiply that by 1.1 again. Let me just move this over. Here we go. I'm multiplying that by 1.1 again for year 2. And here comes the tricky part. They don't really care what 1.1 times 1.1 times 200 is, because they just care about what A is equal to. And A is 200's coefficient. So 1.1 times 1.1 is equal to A. So all we need to do here is take 1.1 and multiply it by 1.1. So 1 times 1 is 1, 1 times 1 is 1, put a 0 for our next line, and we have 1, 1 again. We add these 2 rows, and we got 121. I have 2 decimal places here, so I need 2 decimal places total here. And my final answer is just 1.21. This is going to be one of the harder percent questions that you're going to see on the SAT. You're going to see so many questions as you work through practice tests. We're just knowing when you see increased by 1%, you take that percent, express it as a decimal, and you add it to the number 1. That alone helps you pick the answer without doing any other work. So for number 19, if you haven't already taken this test, I want you to just take a second and without showing any work, putting a pencil on paper, think about what the answer is. And I'm just gonna give you 20 seconds. So I'm gonna count to 20 in my head and see what you guys put here. Okay, so this is a no calculator section. And on the SAT's no calculator section, whenever I see a system of equations, so I see 2 equations with 2 unknowns, this is my first clue. I have 2 equations and 2 unknowns. My second clue is they're both in standard form. And then my third clue is they want a combo of variables. They don't just want to know what is X equal to or what is Y equal to. So if I was in class in school, I would want to use elimination or substitution. So I would first solve for X, and then I would plug that into the second equation, and then I would solve for X, and then find Y, and then add 5X plus 5Y, and that's a lot of work. And a lot of students do a lot of work for this question. Or I could multiply this equation by 2 and multiply this equation by 3. So I can subtract one equation from the other one and eliminate my Y, but that's a lot of work. And on the SAT, no calculator section, before I do any work for systems of equations, I first see what happens when I simply add one equation to the other equation, or subtract one equation from the other equation without changing them at all. So we're just gonna draw a line here, and I'm simply gonna add the two equations, and that gives me 2x plus 3x is 5x, 3y plus 2y is 5y, and 1200 plus 1300 is 2500, and that's my answer. 5x plus 5y is 2500. And that's why just thinking, pause, and think is so important on SAT math, to not just dive in immediately and do what you were taught in school necessarily. Think critically. This rewards critical thinking. So think, is there a way to get to the answer without doing a ton of work? Okay, let's look at question number 20. This is going to be our last question for today. And then I'm going to give you just a minute to fill out an evaluation for our workshop today, which will really help me plan future workshops that will either be similar to this one or I'll make some changes. It just gives me some feedback to know if you enjoyed today and what you maybe would want more of in the future or you'd like to change. Since you could see me for the last hour or so, I could not see you. So I don't know, did you love it? Did you hate it? What are your thoughts? And I'd love to hear from you guys. Okay, so for number 20, we see u plus t equals 5 and u minus t equals 2. What is the value of u minus t times u squared minus t squared? So this is the last written question. So technically it's the hardest, and it's easy to kind of get intimidated here and think, okay, do I need to solve for u? And then plug that in there. What should I do? And this is where knowing the core concepts are so helpful. If you see something that can't be factored, that's where you're going to begin. So we can see here u squared minus t squared is just like that core concept of x squared minus y squared factors to x plus y times x minus y. So we're going to start with that. That's u minus t times u plus t. And then we still have this u minus t. So we can rewrite that whole expression as u minus t times u minus t times u plus t. And then when we look at our given information, they tell us here that u plus t equals 5. So I can just say, hey, that is 5, my u plus t. And, oops. Let's use this color. U minus t is 2. So each of these we can just make 2. So really we just have 2 times 5. And that's 4 times 5 or 20. And that's our answer. Super quick question. Factoring, so important on the SAT. It's not going to go away. Solving equations for X, also not going anywhere. If you felt a little rusty on any concept that we looked at today, I really want to encourage you to go back this week. Don't have too much time go by before you reattempt these questions on your own and kind of reinforce these concepts because they're so important for test day. So I just sent you all a link to an evaluation. It's totally anonymous. I welcome feedback. I really appreciate feedback. So if you just want to take a minute and fill that out, and I'm just going to hang out here too for a minute or two and see if anyone has questions on concepts that we covered today. So I know we went through quite a few things. As I wait to see if anyone has questions or needs me to go back to a question or concept that we covered. I just want to retouch on a couple of things. So I am going to send you the worked out solutions again. You already have it in your email. Also, I'm also going to send you a link to the SAT boot camp that I have on YouTube, and I walk you through the whole core concepts handout in that for each section, including the math section. That's a great starting point, especially if you're going to be taking the calculator workshop on August 31st at the end of this. When is the calculator workshop? No, the calculator workshop is on September 14th. Today is August 31st. Yeah. If you're going to be taking the calculator workshop in 2 weeks on September 14th, I really recommend that you watch the boot camp if you haven't had a boot camp with me before. And here is the link to the other workshops in case you haven't signed up for those yet. And I don't see any questions yet. I'll still give you guys a minute if you have any. And just to reiterate too, it's really important with SAT prep, especially for math, to retake these sections. It's not enough to only take the math sections one time. After you have a couple of practice tests under your belt and you're feeling more comfortable with them, then you can start actually timing the sections. And once you're only missing a minimal number of questions, so not that many, in the last couple of practice tests you take, you can stop retaking the whole sections. You can just retake the questions that you missed. But initially, it's so important for you to retake the whole section because I want you to reinforce the concepts that you don't know. And I also want you to become faster and more comfortable, more confident with the questions that you already knew how to answer. So it's really important to not just pick out the ones that you missed for the first couple of practice tests. I want you to retake the whole sections. Let's see here. Somebody asked, I heard somewhere that some SAT practice tests of the 10 are more realistic than others. Is that true? So practice tests 6 through 10 from the College Board are more recent. So they are going to be more similar to what you're going to see on test day. I still love having students use 1 through 5, especially when they first start practicing and getting ready for the SAT, because there are a lot of similarities even with those practice tests, especially for math, and useful concepts for test day. You can also Google SAT QAS practice tests, and those are tests that are unofficially released by the College Board. So every March, May, and October, the SAT allows students to order the QAS. It's the question answer service. So students who take the SAT on those days can see both the questions and their answers, which is really helpful when you're prepping for the SAT. But those tests are only released to the students that took the SAT on those days. After they've been in circulation for a year or two, then those tests become official practice tests that anyone can access. But you can get your hands on them through Googling. You can also email me and I'd be happy to share some of those with you if you want extra practice. But I wouldn't really start even worrying about the SAT QAS practice tests until you've worked through practice tests 1 through 10 that are officially released by the College Board. I always have students work on those first. And I will give you guys another minute if anyone has a question. That was actually a really good one. That was a good question. For the calculator section, I know we didn't touch on the calculator today. I do recommend, and I'll write out the calculator name here in the chat, I strongly recommend the TI-84 plus CE specifically. If you do not own that calculator, I recommend borrowing it from a friend, learning how to use it, or purchasing one new. If you live in Tampa Bay and you're near the Safety Harbor Public Library, they have a couple of those calculators that students can actually borrow the same way you would borrow a book, which is pretty awesome. And they're brand new, in excellent shape, and you can use, I've had students use them on test day for their SAT, the calculator borrowed from the library. It's definitely worth it to either borrow it from a friend, borrow it from the library, or purchase it new if that's financially feasible for you. Let me see if there are other questions. I don't see any more questions. I'm gonna sign off for today. Thank you so much for joining me. I hope you have a much better understanding of the No Calculator section, and also just how to improve your score in the section. It is a gradual process. Don't get disgruntled in the beginning if you take your first couple of practice tests and your score doesn't exponentially increase or jump from one test to the next one. It really is a marathon. So the most important part, especially in the beginning, is learning from your mistakes and going back and reviewing, memorizing the concepts and formulas and equations. And I have seen so many students really have major increases in their scores with math, and for some it takes longer than for others, but I would at a minimum work through all 10 SAT practice tests and retake those math sections. So important. Okay, everyone, I hope you have a wonderful Monday evening. I hope to see you for future workshops. Thank you again for your time today. Bye-bye.